Matsuda's hybrid metal 3D printer, LUMEX, has the potential to play an active role in a wide range of industries. For example, in Fukui, the location of Matsuda's headquarters, eyewear production is thriving, accounting for over 90% of all eyeglass frames manufactured in Japan. Even in this traditional eyewear making industry, LUMEX is expected to make a significant impact. This is a mold manufactured with LUMEX for forming eyeglass frames. With LUMEX, only the additive manufacturing is performed, while the cutting process is carried out as a post-processing step. Although it's not visible from the outside, what makes this a 3D printer specific technology is that this mold contains an internal three-dimensional cooling channel. Please take a look at this. This is a mold manufactured using a conventional process. In the injection molding of this eyeglass frame, the challenge lies in the fact that only straight cooling channels can be incorporated for such a complex shape. As a result, not only was productivity low, but the defect rate was also high. The solution is this mold, manufactured with LUMEX. Thanks to the additive manufacturing technology, it is possible to place three-dimensional cooling channels in the optimal locations. As a result, we achieved over 20% increase in productivity compared to the conventional method and successfully reduced the defect rate by more than 80%. You might be wondering about the manufacturing cost of a mold produced with LUMEX. It's true that the time involved in 3D printing can in some cases make the overall cost higher than traditional methods. That said, this mold is designed with several innovative features that can help offset those costs and deliver greater values over its life cycle. First, take a look at this shape. This design is full of ideas to reduce the build volume. The build volume is directly linked to build time. Reducing any unnecessary volume, that's the key. The other point is reducing post-processing work by minimizing warpage. Adjusting build conditions and table temperature is effective for reducing warpage. But this street design also plays a key role in minimizing it. As a result, the mold cost can be reduced to 1.1 times that of the conventional method, and if the number of shots exceeds 5,000, a LUMEX produced mold offers better cost performance. In this mold example, the machining spindle, one of LUMEX's key features, was used only for base plate centering, while the cutting was carried out later on the machining center. The reason is simple. This approach was more advantageous in terms of both speed and cost. However, if you want to reduce labor hours with limited personnel, you also have the option of performing the cutting directly with LUMEX. In fact, such needs have been increasing in recent years. This flexibility, the ability to choose how to use a spindle function according to your objectives, is one of LUMEX's greatest strengths. It might just help solve your challenges as well. Please feel free to reach out to us anytime.